So hello everyone, welcome to my YouTube channel, and today I'm going to discuss about a problem which I will going to share now. Okay, let me share the screen. Okay. Okay. So hello everyone, welcome to another session or another video in this YouTube channel. So today I'm going to discuss about a counting problem. The solution is due to me. And here is the view of this counting problem. So here is a view of the puzzle. So there are 13 ways to underline some or all or none of the three dots in a row. How many ways are there to underline some or all or none of the 10 dots in a row? So before beginning the video, I wanted to tell you guys that I will actually solve the problem for any general n, not 3 or not 10, for any general natural number n. That means for any general n, any general natural number n, obviously. And what are natural numbers? 1, 2, 3, 4, 5, 6, and so on. So what is the statement of the problem? That is the biggest thing. It's okay. So there is no particular statement. This was just a puzzle type view, you can see, right? Okay. Let me start. Okay, so you can see three dots here, right? And we are trying to underline below these dots. In how many ways we can do it? For example, we can take no dots, no line under these dots, or we can take one line or no line between these two dots, or you can blank the first dot, then dot on the second, then draw a line on the second dot and blank the third dot. So, and first two dots blank and blank on the line on the third dot, or first two dot we covered by a line, then no line on the third dot. Then we can draw none, first dot has no line, then we can draw two dots, there is a line. First dot has a line, there is no dot, there no line in between, and there is a line on the last. And in this way you can see that first dot has no line, second dot has a line, third dot has a line. Again you can see first dot has a line, second dot has a line, third dot has no line. Or you can have a line on all the dots, or you can have a line on first two dot or the last dot, or you can have a line on the first dot and the last two dots, or you can separately have a line on each of the dots. So how many ways you can do it? The problem is actually asking this. How many ways you can actually do this lining business of along the dots when there are n lines? So you can see, so let me first explain the idea. So my idea is actually constructing through induction. Okay, construction, what does it mean? Construction through induction. That means I will predict the n plus 1th stage through nth stage. That means what is the behavior of the problem in n plus 1th stage if we have predicted the n plus 1 stage. That means what is the nature of constructing the n plus 1th stage from the nth stage, and we will do it for smaller n's and then try to generalize for any large n or any n, right? So let me okay, so before beginning the problem, I must say this problem I had collected from James Stanton LinkedIn post. Okay, that's fine, so let me begin the proof. So you can see here is a view of this problem again. So you can see, so first some idea of notation. Okay, so you can see that if there are two balls or two dots, so along this, okay, let me say, I will not say dots, I will say it box. If there are two box, we can underline these two box. If there are two box, my drawing is not that good. If there are two box, so we can underline, if we underline under this, okay, sorry, so if you have two box, if we underline this, sorry, wait, okay, so if we have, so idea of notation. So instead of calling it dots, I will call it box. So if we have a box, two box, if we underline this box, we will call it 1. If we underline this box, we will call it 1. If there is no underline between this box, if there is no underline below these boxes, we will call it 0. 0. That means if there is a, for example, and if we have this scenario, we will call it, underline this box, 0, 1. Now you can see there is also a pseudo line in between. Draw this pseudo line. That means a line for solving this problem. I will call it pseudo line. This pseudo column line is actually can have a case. What is a case? So when you have two box, there is a scenario like this. So this pseudo line, pseudo column line is intersecting this row line. That means in this case, for this case, this pseudo line is actually intersecting this line, right? This pseudo, I mean for this pseudo line is intersecting this line. If this pseudo line intersect this line, we will call it 0. We will call it, if this pseudo line intersect this line, we will call this scenario 1 in this position. That means we will call this scenario 1. That means if the line intersect this pseudo line intersect this row line, we will call it 1. And if the pseudo line doesn't intersect this, for example this scenario, this line was not there, and so the pseudo line is not intersecting the row line, we will call it 0. So with this, what is the thing? So with this, let me again back to the previous step. So let me erase all this stuff. Okay, so let me erase all this stuff. Okay, so come back to this. So you can see this. Okay, so this box, so draw this 5. So n equals to 2. N equals to 2. We have 5 scenarios. N equals to 3. We have 13 scenarios. So first let me show you that there n equals to 5. 2 has 5 scenarios. What is those 5 scenarios? We have no underlines between these boxes, or we have a first underline, second underline, or we have a this underline, or we have what? This underline, this underline, this underline, or we have, first we have no underline, no underline, no underline, or we have this underline, or we have these two underlines, right? Okay, so in this case only one scenario has the cut. That means only this pseudo line cuts this row line for only one scenario. So what is this scenario? Corresponds to the binary string we defined in the before notation. So we have a 0 here, no line under this box. So first is 0. Now there is no line, so pseudo line is not intersecting the row line, so again 0. This line, there is no line here, so again 0. Again, what this corresponds to? There is a line here, so 1. No intersecting pseudo line, so intersecting with pseudo line 0, and no line under this box 0. So what this scenario corresponds to? This scenario corresponds to this particular scenario. What is this particular scenario? This particular scenario is just the it is just 0 because no underline. Again this pseudo line is 0. Again this 1. Again you can do it like 1. Pseudo line is intersecting, so 1. There is a line under this, so 1. Again, what is this? No pseudo line is intersecting, but there is a 2 line under this, so 1, 0, 1. So we have 5 cases. So 0, 0, 0, 1, 0, 0, 0, 0, 1, 1, 1, 1, or 1, 0, 1. So you can see that when we have these two balls, I mean these two dots, this line is very important, and this pseudo line is playing a very important role. So there is what is so now you can ask, so you can see that if you know this n equals to 2 scenario, you can actually kind of copy paste this scenario over the all possible case. How? Okay, so you have so please see this note, please see this picture very carefully. Okay, please see this picture very carefully, because I am extending from n equals to 2 to n equals to 3. Okay, so you can see if we have two box like this, if you have two box like this, and you want to extend the scenario of these two box from n equals to 2 to n equals to 3, what we will do is we will actually repeat. So this, if you leave this box and repeat the argument here, we have only these possibilities only. For these two box also we have these two possibilities. So if this box is 0, so we need to care about what are the possibilities in this set that ends with 0. Okay, what are the possibilities? There are these two possibilities. These two possibilities end with 0. And what are the possibilities that begins with 0? Again, so these two possibilities actually end with 0. And these two possibilities, this right possibilities are end with are begin with 0. So if there is a 0 here, we can begin the string with these two possibilities. Why? So we have already 0, so this 0 is already 0. So we need to plug the next 0. If there is a pseudo dot here, so we can plug it 0. If there is no dot here, we can, okay, 0 0 1 0 1 0 0 0 1 0 1 0. Okay, so you have a 0 here now. Okay, so this, how many zeros? So this is starts with 0, so we can have 0 and 1, right? Because if this pseudo line is not intersecting, if this pseudo line, so there is a line here, and so there is no line here, so there is no line under this box, and suppose there is a line under this box, so 0 1, so this is the scenario, and we have 0 0. If there is no line under this, no line, we have a 0. Then what we are actually having, so if we have 3 box, if we have a 3 box, let's draw it here. So we have a 0 here, right? So we have the string like 1 0 0. This is a scenario, this can be this scenario. So we have a third set box. Now these two box, these are the two consecutive box. Okay, so these two box, so these two, so there are two possibilities from here. Either, so what are the possibilities? So let me check. So we have end with 0, this end with 0, and this 2 begins with 0. So what is the possibility? So we can have, so this end with 0 and begin with, so we need to begin with the this 2, right? These two scenarios. So what can be there? So this can be a 0 case. So let, so how, what is the possibility? Suppose there is an underline on here, so there can be a 0 here, there can be a 1 here also, but we need to start with 0. So this is a 0 starting 0, so there can be a 1 here, 1, and there can be a 1, right? 0 1 1 is a case, 0 1 1 should be a case, 0 1, no, okay, wait, okay, let me explain it again. So you have, suppose you have, suppose you have 2 box, okay, suppose you have 2 box and we want to extend it to the third box. Suppose we have this scenario, that is 1 0 0. So we know that this 2 box has only one of these possibilities. Only these possibilities have. So let me write down the scenarios. Scenario is 1 0 0 0 0 0 1 1 0 0 1 1 1 or 1 0 1. So these two boxes can also have same possibilities, and these two boxes have a 0 in the middle. So what can be these two scenario? And how many string starts with 0? These two strings start with 0. So this can be 0 0, or this can be 0 0 1. So from this case we have a two string. From this case we have two string. That means if we have a box like this which is 0 0 0, we can actually take this to 0 0, or we can actually take this to 0 1 0 0 1, right? Okay, or so from now so you got the idea how we are extending, right? So you got the idea. So you have a 2 0 and you can have a third 0, then third 0's number of choices with starting with 0 is this and this, so we can actually have this or this. These two are the described scenario for n equals to 3, right? Got it? Now we are actually going to discuss. So in this way we will construct how we will construct from n equals to 2 to 3. So first we have 0 0 0. Now we have the possibility that this can be 0 0 0, or this can be 0 0 1, because this, okay, remember this 0 and this 0, if there is a 0 here, there should be a 0 here, and this 0 and this 0 are just for same box. You got it? This 0 and this 0 is for the same box. This 0 and this 0 are for the same box. So there are two possibilities. Let me draw a double line. So there are two possibilities, right? Okay, from this. So now we have another possibility. What is that? 1 0 0. And what are the possibility from here? From here we have 0 0 1, and from here we have 0 0 0. These two 0 are same, and we have another two possibilities. Okay, so again, so you draw now 2 0 cases are done. Now we have 1 0 1, and from here how many have 1 at the starting? There are 3 that has 1. Okay, let me pull it here. There are 3 that has 1, and what are those 3's are? That means 1, so this can be also 1 0 1, this can be also 1 0 0, and this can be also so this can be also 1 1 1. Remember, this one and this one are equal. That means we have 3 possibilities. Okay, and what are the third case? Third case is actually 0 no, not 0, 1 1 1. And how many have 1? These are similar to this. This is actually 1 0 1 and 1 0 0, or 1 1 1. And what is the last and final case? That is so we have covered from this 5 set of numbers, we have covered all numbers except the case what? 0 0 1, and from this we again have 3 case 1 0 1, we have again have 3 case 1 0 0, and we again have another case that is what 1 1 1. So how many new box we have? So we have 1 2 3 4 5. So number of boxes we have in the n equals to 3 case is actually the number of ways we have done it. So how many? 1 2 3 4 5 6 7 8 9. This is 7, okay, 7 8 9 10 11 12 13. So for n equals to 3 there are 13 ways. Cool, we have find the generalization, bro. Okay, bro. Okay, guys, so we have find how to extend from n equals to 2 to n equals to 3. I hope it is clear, right? Now we will do a simple generalization. So suppose so we have for, so you can see for n equals to 2 there are 5 ways, and for n equals to 13 there are 13 ways. So what is for x in, suppose xn plus 2 denotes the number of ways to do the task. Suppose xn denotes the number of ways to do the task for n dots. Then so xn plus 2 is the linear combination of 2 into something plus 3 into something, and why 2 into something 3 into something? Because you can see that in this case there are two of these, either end with 0. If end with 0 there are 2 branches getting out, and if end with 3 there are 3 branches getting out, and these 3 branches are all same, and these 2 cases branches are all same. So question is how many 2's we need and how many 3's we need. So the number of 2's, so you can see you have a set, right? So the number of 2's is actually equals to, for each box, from each box, okay, from each box we can set up a new box. From each box, from the nth stage we can actually go to the n plus 1th stage, and from each box in the n, so each box, right? So we have each box, so there this is the n plus 1th stage and this is the n plus 2th stage. We will prove the number of 2's in the n plus 2th stage is actually equals to the number of ways that this can be done in the n ways. So in box, so there are, okay, so xn plus 2 is, so we have n plus 1. Now n plus 1 has how many 2's? N plus 1 has precisely, n plus 1 has how many 2's? N plus 1 has precisely, okay, say, okay, how many 2's? So n plus 1 has how many 2's? Exactly the number of boxes in x, this n plus 1, so this 2, so you can see, right? Okay, let me explain it well. So you have a box in nth stage, and you have a box in n plus 1th stage, and n plus 1th stage, and you have a box in n plus 2th stage, right? So xn plus 2, okay, so xn plus 2 is the number of choices of these 2 and 3 boxes. So how many ways there is a, a 0 and 0 here. The number of 0 here in this n plus 1th stage is actually equals to the number of 0 in the n plus 1th stage, right? N plus 2th stage. And how many zeros in with this? So for each in its stage, for each 2 in the, for each, so you take every branch, for every for every arrow from this init stage there is a 0 here, right? So you can see, right? So go to the n plus 2 itself. So for every there is a 0. That's see, from here we can actually have a 0, from here we can actually have a 0, from here we can actually have a 0, from here we can actually have 1 0. So for every init stage, right? So for every from every init stage, the number of choice in the init stage, the number of arrows we can come out from the init stage, number of boxes in the init stage. So you have these are 0 and 0, right? Okay, so the number of boxes in this init stage is xn, right? From each of these box we can associate a 2 here, right? From each of these box we can associate a 2 here, right? Why? Because from each of these box there is a 2 from each of these box we can find a sequence that end with 0, right? Yes or no? From each of this box we can find a sequence that end with 0, right? Why so? Because you can see, right? So you can take any box and you can go to a starting with 1. For 1 there are 3, and for 2 there is a ending with 0 is always there, right? For example, you can go here for smaller case. So you see you have a 0 here. From each of these box you have a 0 here, you have a 0 here, you have a 0 here. So the number of zeros in this stage is actually x. So the number of zeros that begins here is that. So the number of zeros means 2k's. So the number of 2k's here is actually the number of 2's here. You get it? That means if you have a 0 here, here is a 0, and for each 0 it has come from one of the box, so any one of the box of xn, so 2 times xn. You get it? There is a 0 here, and this 0 has a match, and each of these 0 come from any of the box in init stage. So this is xn, and from each of these there is an arrow. In xn plus 1 xn plus 2 comes from each of these there is an arrow. So this is actually xn plus 1 minus something. And what is this minus? That minus, there are 2's. Minus is actually in this stage there are xn such 2's, so minus xn. In other words, xn plus. Okay, so there is a computer problem, guys. Sorry for the glitch. So I'm back again. So what we are doing, so where we are, so we have proven that xn plus 2 equals to 3 xn plus 1 minus xn, and x1 equals to 2 and x2 equals to 5. So if you know Fibonacci sequence, then you will get xn equals to f of 2 n minus 1 with f of 1 equals to 2, and f of 2 equals to, you will get Fibonacci sequence with f of 1 equals to 2 and f of 1 equals to 2 and f of 1 equals to 2 and okay, sorry for the glitch again. So and f of 5 f of 3 and f of 3 equals to 5. So and the Fibonacci relation is f of 2 equals to 3, where Fibonacci is defined by f of x fn plus 1 equals to fn plus 2 equals to fn plus 1, and f of 1 equals to 2, f of 2 equals to 3, and f of 2 equals to 3, and f of 3 equals to 5, f of 4 equals to 8, f of 7 equals to 13, and so on. So that's it. So we have found that xn equals to this, where first term of the Fibonacci sequence is 2, second term of the Fibonacci sequence is 3, and so on. That's it. So we have solved the problem. So finally we have xn equals to f of 2n minus 1, where f1 equals to 2 and f2 equals to 3 is the first two terms of Fibonacci sequence fn plus 1 n plus 2 equals to fn plus 1 n plus n equals to 1. Quite. And this is the solution. I hope you liked the video. So let me end this. So I hope you guys liked the video. Thanks for watching the video and hope you enjoyed the video and concepts. Like, share and subscribe. Goodbye until next time. And here you can see my photo, and do comment on my videos. I will share solution of the most interesting problem. If you comment on my video some interesting problems, I will do share the solution of the videos. I will do share the solution of the most interesting problem I found in the comments. And follow me on LinkedIn, follow me on anywhere. I mean, if you want to know some doubt, if you want to clear some doubt, chase me anywhere you want to, like. Preferably I am most active on LinkedIn, so you can actually check me on LinkedIn or maybe Instagram, Facebook, anywhere. So this is me, and bye bye.